Purpose now is to talk about autoencoders. Is a type of a neural network that gets data, here is the input features, and output the reconstructed features. In the process, we are getting to the lower dimensional space of the data, and we can use it for various tasks. Namely, think about something that gets inside here, maybe an image, maybe data or something, maybe high dimensional data. And in the process of the neural network, from layer to layer, we are getting the number of nodes in the layer to be smaller until we are getting to this smallest layer. This process is called the encoding part, encoding network. And then after this, we are trying to reconstruct the input data in this process where the layers are getting bigger and bigger. Usually, sometimes the network is very symmetric until we are getting to the output layer, which should reconstruct the input layer. Therefore, the network learn how to reconstruct the data it gets. Now, we can use it for various tasks. We are getting here the data to be condensed, more condensed, and using less and less nodes, namely less and less dimension. Therefore, after the network learned and was trained on the data, this layer, the latent space, the representation, the lower dimensional representation can represent the input data as lower dimensional data. It's like doing principal component analysis, PRINCA, the same concept of taking the data and uh, project it to lower dimensional space and trying to catch the most important component of the data so we can present it in lower dimensional space with the most important values. Maybe combination of values, maybe combination of features from the input space, but lower dimensional space with the most important components. So encoding part, latent space, lower dimension of the data, and decoding network. We can also use it to detect anomalies, namely train the network on data and then test the network. And when we get a new sample that the network gets very wrong, it probably an anomaly. So we can train the network on data until the network learns how to reconstruct the data, then take it to the real world, starting to insert data every time we expect to get very similar result from the network until we get a sample which we are getting a very different result, namely this sample was very anomalous, namely anomaly detection. You can also use it to generate data. We are taking input and the network trying to generate new things like new images, creating images from words, and etc. etc. So as you can see here, autoencoder, it has an encoder part that compresses the input data, the coder part that reconstruct the original data. We can train it using like mean squared error, like we are doing in ordinary neural network. We have input layer, hidden layers, and output layer, the reconstructed data. This is the structure of the network. We have the input, encoder, latent space, decoder, and output. And we have several types of autoencoder, like the noisy autoencoder. We are trying to reconstruct the original input from a corrupted version, a sparse autoencoders, hidden layers to encode the model in more compact representation, convolutional for images. And here you can see the application, dimensionality reduction, like we said, like the PCA, to preserve important information and to make the data in lower dimensions. Anomaly detection detects some weird inputs to the data, input denoising, data generation, like we said on the images, feature leaning, autoencode linear useful feature from the input data, which can be used as input for other machine learning tasks. I don't know, like take the data, take this part, and this will be the input to the new network because this learned the most important parts of the input, the most important features. I don't know. So encoding, decoding, lower dimension, input, reconstruction, and as you can understand, the loss function, the error will be how much, for example, the reconstructed data is different from the input data using mean squared error, for example, and all the other things can be the same as other neural network with the weights, with the activation functions, sigmoid, ReLU, hyperbolic tangents, and etc. etc. So this was about autoencoders. Thank you very much. Maybe we can see some example of how autoencoders can denoise an image and how autoencoders can do a lot of things. But thank you very much. Here you can see how the autoencoder reconstructed digit after compressed representation. And okay, so that's it. Thank you very much. This was about autoencoders. If there are any correction or mistakes, I'm sorry and please correct me. And that's it.